Welcome from the International Training Center at San Diego State University and the studios of KPBS TV. I'm Dr. Michael Reel, the moderator for this teleconference. We are broadcasting live via satellite in the second of 4 sessions on the topic of telecommunications for education and professional development. It is my pleasure to welcome our experts and all our participants today from Mexico and Latin America. We welcome approximately 90 participating sites and many leaders of business, government, and education. This series of teleconferences is designed for the non-specialist interested in using learning technologies for success locally and globally. Our certificate program offers you new credentials in employing today's most exciting and useful technologies. Let me remind the coordinators in each receiver site to collect attendance sheets and mail them back as soon as possible. Include the evaluation forms filled out by those interested in receiving the certificate of participation. Our topic today, Videoconferencing and Telecommunications, Technology and Training. What is a teleconference? Well, it is precisely what we are all engaged in together today. It is people interacting at a distance through technology in real time. A teleconference can be as simple as a telephone conference call, but a video conference means visual and audio interaction through the communication medium of television. People hear and see and interact through audio-visual technology. This video conference calls for the collaboration of engineers, financiers, educators, and artists. It can be used by government and business for training, planning, or negotiating. It can be used by schools for instruction and feedback. A video conference explodes the walls of the boardroom or classroom and opens an event to many thousands of participants separated by thousands of miles. Our experts today will explain how to understand, plan, and operate successful video conferencing and telecommunication. Take today and this teleconference as an example. Many months ago, planning began to arrange facilities, identify participants, and prepare materials. People are the most important component, of course. You in Toluca, Jalisco, Sinaloa, Colima, Chiapas, Argentina, and other downlink sites are the reason for this video conference. You must have satellite downlink receivers and television sets to be linked with us. We, in turn, must have television cameras and production facilities connected to our satellite uplink. Thus, between us today and connecting us are cameras, cables, microwave transmissions, satellites, and television receiver sets. There may also be optical fibers, compressed video, digital technology, and other components between us here in the KPBS TV studio and you in a given site. We employ several satellite frequencies to provide for simultaneous translation. The crucial return link is by telephone lines for the transmission of voice messages, a phone question, and for the transmission of text, a fax. There must be an effective return link for any teleconference. Our event must be two-way, from here to you and from you back. For many of you, discussion of the communication technologies employed in video conferencing is a review and reintegration of what you already know. For others, it may be a great deal of new, detailed information on technologies and applications. For still others, this may be an opportunity to convince your colleagues of what you already know, the techniques and advantages of video conferencing. Whatever your purposes, We hope you will find this material of interest and of genuine value to you in developing telecommunications for education and professional training, the theme of this video conference series. Before we turn to our guest experts, let me note the payoffs of video conferencing and telecommunication, which can be many. A huge amount of transportation cost and time can be saved. Instead of flying people from all over Latin America to a central location to study teleconferencing, this teleconference can come to you, saving airline tickets, hotel costs, and time lost away from work and teaching. Transportation can be replaced by telecommunication, not only saving resources, but also opening up the process to many additional participants who could never have flown to a central meeting place. As a consequence, telecommunication itself may appear expensive, but it often saves a much larger amount of money and increases the outreach of your activities. Teleconferencing may also improve student and employee morale, loyalty, and value, and it may improve the speed, quality, and ease of communication throughout your organization. Dr. Farhad Saba is an expert on video conferencing and is our guest today. Dr. Saba, could you briefly indicate some of the specific organizations that you know of that have successfully used teleconferencing and video conferencing?
Yes, of course. The example of Apple computers comes to mind. Apple computers, when they were rolling out the Macintosh 2SI series of computers, organized a teleconference from the site of the manufacturing of the computer in Singapore, and they did an international teleconference in which viewers had an opportunity to interact with those people who were responsible for designing the computer, manufacturing the computer, and marketing the computer. The second example that comes to mind is Digital Equipment Corporation. Once you buy a piece of equipment or a software, then you would like to be kept abreast of the development of that product. And Digital Equipment uses teleconferencing to keep in touch with customers and end users and keep them informed of the development of the product and the software.
Thank you. We will be hearing a great deal more from Dr. Saba in a few moments. First, we are fortunate to have with us today a representative from Telecomunicaciones de Mexico. Juan Manuel Zamudio Sea is manager of satellite control at Telecom de Mexico. He has played a central role in the development of the Solidaridad satellite system. He holds a degree in industrial engineering from the Universidad Autónoma de Hidalgo, and in 1988 was awarded the prestigious Lázaro Cárdenas Medallion from the Instituto Politécnico Nacional. He is deeply involved in the development of space communications in Mexico and has represented the country in international forums on various communication media, including radio, digital signaling, microwave, and satellite usage. Mr. Zamudio.
Telecom is an organization created officially in November of 1989 with infrastructure from two agencies of the federal government of Mexico, the Dirección General de Telégrafos Nacionales and the Dirección General de Telecomunicaciones. According to Mexican legislation, Telecom is designated as a decentralized public agency. In addition to providing signal transmission and satellite network services, Telecom provides communication services via telex, public fax, telegrams, and telegraphic wires nationwide. It also operates a data network for package services to commercial clients. Telecom is one of the two largest telecommunications enterprises in Mexico, along with Teléfonos de México or Telmex, a well-known private company which provides fixed telephone services nationally and internationally, as well as cellular telephone communications. Mexico considers communications via satellite a strategic resource, and its political constitution establishes that only the federal government can provide these types of services, which currently are under telecom's jurisdiction on an exclusive basis. A major component of the infrastructure under telecom is the national satellite system, which consists of the satellites Morelos 2 and the recent Solidaridad satellite system, comprised of Solidaridad 1 and 2, with national and international service areas. Mexico began its space communications involvement in 1968 as a result of the Olympic Games held in this country by inaugurating the Earth Station in Tulancingo, Hidalgo, and since 1981 established a domestic satellite system with leased capacity from Intelsat. In 1985, with the launching of the Morelos satellite system, the benefits of space communications became a tangible reality for Mexico and other Latin American countries. The Morelos 1 satellite was placed in orbit on June 17, 1985. The Morelos 2 satellite, launched 5 months later as a reserve for Morelos 1, was placed in a storage orbit in order to minimize the fuel costs and to prolong its useful life. The Morelos 2 satellite was placed in its nominal orbital position and became operational on April 18, 1989. The end of the useful life of Morelos 2 is estimated for the fourth quarter of 1998, while the Morelos 1 was removed from its orbit in March of 1994. In order to meet the increasing demand for services required by users from different sectors and to be able to replace the Morelos 1 satellite, Telecom undertook a major effort to plan and implement a new project which would meet present and future needs of Mexico and the region, assuring the continuity of present services while expanding its international service area. The Solidaridad satellite program was thus created. The Solidaridad satellite system consists of 2 spacecrafts, model HS-601, designed by Hughes Aircraft, with a useful life of 14 years. The Solidaridad 1 occupies the orbital position 109.2 west, while Solidaridad 2 will occupy a position close to that of Morelos 1, which is 113 degrees west. Both satellites operate in C, KU, and L bands. As an integral effort of the Solidaridad System project, the Satellite Control Center in Mexico City was expanded to include a dynamic simulator for satellites, a communications testing laboratory, and the improvement of the current monitoring system. Also, an alternate control center was built in the northern city of Hermosillo, Sonora, and the satellite provider, Hughes Aircraft, delivered a comprehensive training, technical assistance, and technology transfer program. The advent of the Solidaridad satellites increases the availability of communication services through greater transmission power, more than 4 times that of the Morelos system, allowing, among other things, the reduction in size of required dish antennas for signal reception. Currently, the Morelos 2 signals can be received effectively with a 12-feet diameter dish antenna. The Solidaridad satellites will require antennas with only 4 feet in diameter. They will have a useful life of 14 years, which represents 55% more duration than its predecessor, with an international service area covering the entire American continent, including 19 countries fully and 6 others partially in South America. On November 19, 1993, the Solidaridad 1 satellite was successfully launched into space, thus culminating one of the most important phases of the Solidaridad satellite project. The Solidaridad 2 satellite will be launched on October 4th of this year, utilizing a launching rocket of the Ariane Space Company from Kourou, French Guiana in South America. Thus, Telecom, as of November of this year, will have the availability of a 3-satellite system, the Morelos 2 and the 2 Solidaridad satellites. The total capacity for C and KU bands will be of 112 transponders or signal retransmission units. With these satellites, communication services will be offered to Central and South America, as well as the Caribbean, through transponders in C-band, and to the United States of America and Canada with 4 transponders in KU band. Currently, more than 3,000 communication signals are being managed with the Solidaridad 1 and Morelos 2 satellites. These are supported by 320 private networks and 13 public networks of digital signals for voice, data, and video, 21 television networks which transmit analog signals and compressed digital video, 42 analog and digital carriers for high-quality audio services needed by commercial radio stations, as well as telephone linkage and rural delivery telephone services. The L-band is also used by the Solidaridad satellites. These frequencies are used for mobile communications on the ground, an application which is fast-growing worldwide. Because of the propagation characteristics of the L-band, 1500 to 1600 megahertz, its use is ideal for moving vehicles, ground, maritime, or aeronautic. It can also be utilized with semi-fixed facilities of easy transportation to establish emergency communications in disaster zones or in areas of difficult access for conventional communications media. The utilization of the L-band will be based on a mobile data communication system, utilizing terminals of the Inmarsat C-type, which send and receive low-velocity messages with the store and forward technique to mobile low-cost terminals. The control center for this system will be operational in October of 1994. Presently, Telecom is in the process of purchasing a control center for mobile telephone communications, which is planned to start operation towards the end of 1995. This center will offer also rural telephone services to small and distant communities. One of the most important projects in which Telecom participates with Mexico's Ministry of Public Education is the purchase of 10,000 satellite antennas and downconverters for distribution to rural communities to extend the national tele-high school education program. This project will eventually increase the average schooling in Mexico from 6 to 9 years. Various other educational institutions, junior college and university level, already have received antennas to receive programs such as the ones we are participating today. Also, businesses, banks, and chambers of commerce and industry, and other organizations in Mexico and Latin America are rapidly joining instructional services such as this one. Modern satellites allow for the efficient transmission from a source site, such as San Diego, California, to many other receive sites distributed in a wide geographic region. The costs and prices for these services have been gradually reduced, making it possible for participating organizations with a good logistics plan to maximize the effectiveness of this service for training and instructional applications in general. On the other hand, technological innovation is making associated equipment and receive antennas particularly user-friendly and inexpensive, so that the future growth of this type of service for educators, businesses, and professionals in general will have for sure no limit. Thank you.
Thank you, Mr. Zamudio, and congratulations on the exceptional facilities and services developed by Telecom. What impressive accomplishments you have achieved, and what great promise you offer for the future. In order to utilize such traditional services, such national services, many connections must be made. To explain this and the overall technology, organization, and potential of video conferencing and telecommunication, we are fortunate to have Dr. Farhad Saba of the Department of Educational Technology at San Diego State University. He has wide experience in several countries and with many technologies and applications. Dr. Saba served as Managing Director of Educational Radio and Television in Iran from 1973 until 1978, and as the Telecommunications Division Director at the University of Connecticut from 1980 to 1984. With 20 years' experience in telecommunications-based education, he has been involved in design, implementation, evaluation, and policy analysis, and has made presentations in France, Great Britain, Afghanistan, Indonesia, Malaysia, Switzerland, China, Turkey, and of course in Mexico and the United States. Dr. Saba is ideally suited to provide for us an overview of the different media available for teleconferencing and the way these media can be put together for effective training and professional development. Dr. Saba.
We live in a very exciting time in which telecommunication has provided wonderful possibilities for teaching and learning. The growth in the use of telecommunications for management, administration, education, and training has been phenomenal. Almost all major companies and educational institutions here in the U.S., as well as major international corporations across the world, own and operate teleconferencing systems. Such systems are used at least for two purposes: corporate training and business meetings. Also, many countries of the world have adopted some form of distance education to meet various educational, training, and other instructional needs in a variety of subject matters for many different audiences. An understanding of telecommunication systems is the key to the design and development of teleconferencing facilities. Therefore, we're going to spend a few minutes on the characteristics of telecommunication media and how they can be of use to you as trainers, educators, and managers. Since the 1950s, when television was applied to instructional purposes on a wide scale, the number, variety, and capacity of telecommunication systems have grown tremendously. Broadcast television is the oldest and the most common means of video distribution. In the U.S., the Federal Communications Commission, or FCC, has allocated a certain frequency range for transmission of television programs in each local area. Local television programs are transmitted over very high frequency, or VHF, that range from 30 to 300 megahertz, and ultra-high frequency, or UHF, that range from 300 megahertz to 3 gigahertz. Viewers use channels 2 to 13 on the VHF band and 14 to 83 on the UHF band to receive local television broadcasts on their television set at home. The range of local television broadcasts are about 75 miles, and the farther you get from the television transmission antenna, the image and sound signal becomes weaker. VHF and UHF television signals are also fragile. They cannot pass through barriers such as tall buildings and hills. Broadcasters use other transmission technologies to overcome physical barriers as well as channel capacity limitations. Channel capacity refers to the fullest extent to which a channel can accommodate the information, such as frequencies and words, to be passed through that channel. In the U.S. NTSC system, or the National Television Standard Committee, 6 megahertz is allocated to each television channel. Microwave transmission is used by broadcasters to relay network programs from one city location to another to overcome distance and physical barriers. The frequency range of microwave transmission is between 1,000 megahertz to 50 gigahertz. Electromagnetic waves in these high frequencies can travel farther and can carry many more channels. Considering the fact that the Federal Communications Commission, or FCC, has assigned 6 megahertz of bandwidth for each television station, 10,000 hertz for each radio station. Microwave transmissions can carry many radio and television programs simultaneously. In many local areas in the U.S., FCC has allocated specific microwave channels to instructional use. These broadcast stations, known as the Instructional Television Fixed Service, or ITFS, operate from a variety of institutions, such as county offices of education or college campuses, and provide instructional programs to students in schools or adult learners in industrial and business sites. Microwave transmission, however, is point-to-point, and by itself does not cover a wide geographic area. For wider distribution and more channel capacity, educational broadcasters and distance educators look towards cable television. Cable television first developed as an industry parallel to broadcast industry and at times in competition with it to provide television services to urban and rural areas which could not receive broadcast television. Cable television literally uses a coaxial cable to distribute video and the associated audio signal to its users. Broadcasters receive a variety of programs from on-air broadcasts and satellite transmissions. They amplify these signals and distribute them from their offices or the head end through a network of coaxial cables to end users at homes, schools, and places of work. In some communities, the cable is placed under the ground or on the utility poles. Cablecasters carry the programs of local broadcast television stations, but since they have many more channels available to them, more than 100 channels in some communities, they also can carry programs that are beamed to the satellite by broadcasters in other parts of the country and from other countries of the world as well. In the U.S., several new forms of programming via satellite have been developed based on the capacity of local cable networks to carry these programs to the end user. For example, Cable News Network, or CNN, an all-news station, and Entertainment and Sport Network, ESPN, an all-sports station, present their programs to their audience via satellite and cable television systems.